Hello everyone, in this video we're going to look at B1024 Lab 4 three-wire control. In this lab we're going to learn how to manage the RSLogix5000 tasks into programs and routines. We learned it in the previous labs, so we can create new routines within the program. In this lab, we will learn how to create new program and design the new routines within the program. Once we have different program, that's what we call the task scope. So this is a new term we learned because we have different programs. So different program will have different task scope. That's part of this lab, the purpose of this lab. The other thing we want to learn is the sew-in technique within the data logic design, and also the how do we choose the instructions on the stop button and the start button. So the first section on the lab, I ask you to create new programs and routines for three-wire control. So just remind you, don't delete anything on your existing program. So I have the file open. So over here we have the main program. This is the default program when we create a RSLogix5000 project. And we have the main routine. Also, we create a subroutine from the previous lab. So on this lab, we want to create a brand new program. It's in parallel with the main program. So if you right-click main task, choose the main program, you can create a new program. I ask you to give the name called 3_ first, then three-wire control. Once we click OK, you can see underneath the main task, not only we have a main program, it's one folder, we have a second folder called three-wire control. This is a new program you create within the project. And after that, you can see right now there's only program tags created underneath the three-wire control. We want to create over here. We want to create 5 new subroutines. So you can right-click and create new routine. So let's look at what's the name. Okay. So first we need to create my main. That's the main program. Then we have 5 subprograms. Right. So let's go here. The first one we can create called my main. So you can see here that belongs to the three-wire control, and also the assignment is main. Right. So click OK. You see the main program, my main created, and also the icon on this program, it has a number 1 on there that indicates it's the main program. If we create more routines called by switch, so on this new routine, you can see on the assignment it's not main anymore, it's just a regular subroutine. Okay, so we have this subroutine. We also need 5 more or 4 more routines. So we just need to create new routine. Routine 1. Routine 2. Each subroutine will have different scenario. So routine 3, and last one, routine 4. Okay, so we have these 5 subroutines created, and we need to create also 5 new Boolean tags. So motor PB1 to PB4, and you can see here these tag names. They are the same tag names as the 4 push buttons in PBs and PLs. So if you remember on the previous labs, we have the main program. If you double click open that program tag, you will see you have PB1 to PB4. But with this new program, 3-wire control, we can create new tags called PB1 and PB2, PB3, PB4, and motor. So you can see with this PB1 to PB4, they have the same name as this one, but they're actually different tags because they have different tag scope. They're within different programs. So you will see later on in this lab. So that's the next section. We want to observe the tag scope. First, we want to create the ladder logic within byte switch. So we want to energize the motor when the controller tag SS has the value of 1. So let's go back to the program. Open my main. So if you quickly add the instruction, you can click JSR, then you will have the instruction right away. So set up the byte switch. So this is from the my main routine. The main routine will call byte switch. So let's open the byte switch, go into there. So because when the SS is the controller tag. If you open here, we have the SS represent the selected switch. So over here, when SS value has 1, we want energize motor. So that means we want exam on SS. Then we output energize motor. So this is the first routine by switch. So when SS has value 1, this exam on will become true. Then we energize the motor. So we want to download to the HMI and then test out. So let me have my HMI open. Once it download, remember turn on the run mode. We don't want to stay on the program mode. Right, so we have the routine running, and now we open the SS switch and the PBPL. So remember that's the previous lab, right? So when you open the SS, the green light is on. When you close the switch, the red light is on. So now let's navigate back to the main. Then open the 3-wire control. So you can see the motor over here. It's flashing. So that means it's on. If you look at the program, the motor is energized. And because the select switch is closed, the exam on become true. And let's go back to the main. And if we open the switch, so once you open the switch, you will see here this is instruction become false and motor will be de-energized. And if we go back to the 3-wire control, that's true. So motor is de-energized. Okay, so this is the first part. You can see even though the SS is on the controller tag, it still can control the output on the 3-wire control. So the next part of the lab, we need to find out the type. Alright, so the type on the 3-wire control buttons. So we have the program tags, and now if we want monitor tag, we click here, monitor tag, we can look at the values. Right now you can see that I have the symbol design on the push button. You can see this button from this symbol is different from PB2. So PB1 is actually normally closed push button. You can see here is connected if you don't press it. When you press it, it becomes open, and in the same time you can see here the value change. If you release button, the value has 1. When you press it, the value over here was changed to 0. So that tells you PP1 actually is a normally closed push button. So over here, we circle over here for PP1 is normal. Okay, so if we press PP2, notice right now the PP2 value is 0. If you press, that value will change from 0 to 1. So that means the PP2 is normally open. Same thing for the PP3 and PP4. Notice color difference, so that's it's being pressed and held right now. So if you press, that should go back to the normal position, which is closed. Okay, so that means that's what the result we can find out. PB1 is normally closed, PB2 and PB3 are normally open, and PB4 is normally closed. The next part, so if we open the folder of main program, we look at the tag value within that folder, the PB1 to PB4, when we press the button on the 3-wire control. So let's try that. The program is running, and we have all the push buttons from the 3-wire control. On the RSLogix5000, if we open the program tags underneath the main program and look at the monitor tag, the values, currently they are 0. So if we press PB1, then watch, is there any value change on here? So no matter we press or release, PB1 doesn't change the value out here. And same thing for PB2. If you press and close, press and release the buttons, nothing changed within the main program. So that is what we found out. So I have a question for you. Why the SS, the select switch, can be accessed in both main program and 3-wire control? We saw that, right? So we can use the SS not only control the red light, green light, and also we can turn on the motor. But in the same time, the tag PB1 to PB4 can only take effect in the program they are created. Which tag property is responsible for this? So what do I mean is, so this PB1 to PB4 can only take effect when you actually press the buttons within this subroutine. You can see here that change, right? But when you press the 3-wire control buttons, that doesn't affect anything, and vice versa, right? So they only take effect in the program they are created. So the reason for that is, you can see here, you can see the reason is tag scope, or because they are controller tag, program tag, or the other term is called public or local. So that's the reason for this part. Also, you can see here, not only they are different tags, also you can see they are totally opposite, different type of push buttons. In main program, we have that as normally open, normally close, normally close, normally open. So on this 3-wire control, they are totally different, right? So because they are different tags, so they can have different setting. One suggestion is that the because the PB1 and PB4 are normally closed, and when you download, sometimes you will see that's being pressed because the value is default at 0. And what you can do is get offline and change the 3-wire control, the value PB1 from 0 to 1 and PB4 from 0 to 1, and then you save the file. So this will be the default value for PB1 or PB4. And if we download the program again, you should be able to see the buttons. So right now it's updating the values on the PLC. So once finished download, you can see the PB1 and PB4, they are at their natural release state because you save the value as 1. For normally closed push button, if it is 1, it is released state. So that sometimes will help you. You don't have to press the button anymore after you download the PLC. Next section, we look at the 3-wire control and seal-in technique. So on up here, I have a picture of this motor starter. These two terminals here is the coil, the motor starter coil that in the PLC ladder logic represented by the output. Oh, sorry, not PLC. It's the electrical ladder logic. So that's the coil represented there. And then we have the stop button as the normally closed, and start button as the normally open push button. And notice here, this M1 is a normally open contact, and that actually is on the corner of this motor starter. It's what we call auxiliary contact. It's normally open contact. Because it's normally open with this 3-wire control, when you press the start button, this become closed, and then this motor starter will be energized, the coil will be energized, so that will be on. So when the coil is energized, this normally open contact will become closed. So when it's closed, it bypasses the start button. It's like a second pass of the electrical current. So because of this, the start button can be released now. You don't have to press and hold the button. So after you release the start button, you still have this current to go through the second branch to keep the motor starter coil being energized, and because of that, it will come back to make this normally open contact closed. So that will maintain this path to the output. So this is what we call seal-in technique. Over here. So in hardware circuit, the circuit above is the most secure way to start and stop the motor. We'll talk about this on the second part of the video. But notice over here with PLC instructions, we don't have to set up the push button at stop as normally closed and start as normally open. We can have the other 3 combinations. So for example, both buttons are normally open, or we flip that. The stop button is normally open and start button is normally closed. And the last one, both buttons will be normally closed. So with these 3, normally we don't set up the hardware circuit with these 3 setup. But with PLC, we can have different, all the 4 combinations in here. So that is what we will do with the next part of the lab. So we need to get offline and design these 4 different combinations into 4 different subroutines, and use the 4 push buttons on the HMI as start and stop. So for now, we just ignoring the overload contact. So that's this part. So we don't have to worry about it for now. Later on, we will talk about it for the overload contact. So in routine 1, we will use PB1 as the stop button, which is normally closed, and start button as the PB2, which is normally open. Okay, so to start the motor, we need release stop button. So we don't touch the stop button, which is normally closed. So this is continuation from the truth table method. If you think about what we did in the previous lab, we will find the tag value first. Depends on the values 1 or 0, we choose instruction. So over here we have a PB1, which is normally closed push button. Then we release the button, that will become closed, and then PLC will read value as 1. 1 is on, so we use exam on instruction. And for PB2, the type is normally open, but we need press because PB2 is the start button. We use that as start button. So when you press a normally open push button, it becomes closed, and PLC will read value 1. Because 1 is on, we use exam on instruction. Okay, so this is what we decide to use the instructions inside the PLC. And over here on the diagram, it's just the review from the previous one. So now we need to draw the symbol to represent the input-output on the PLC. So we'll have a push button. So first we need to draw PB1. PB1 is a no. PB1 is a normally closed push button. So this is the symbol to draw the normally closed push button. And inside PLC, we use PB1 to represent this stop button. And PB2 is normally open, so we need to draw that button over here. And this symbol, which is normally open push button. In PLC, we have the tag PB2 to represent this input button. On the output, we can have a circle to represent the motor starter, and the tag inside PLC is motor. So this is input and output on the PLC. And we have this instruction selected over here, so we just need to design the ladder logic. So we use exam on. You can see here exam on to check PB1. This is what we decide. And we use the same exam on instruction over here to check PB2. And after that, we will have the output as motor. Sorry about my drawing, it's really hard to control my pencil. So that's the output on the motor because of this, right? And then if we don't do anything, just design like this, we need to press and hold PB2 all the time. Right, so this is what we learned from before. We have a seal-in technique, so we can have a parallel branch over here. here. So over here we use the output to come back to seal the input. So this is the design with the first configuration, PB1 as stop, PB2 as start, 3-wire control. Okay, I think we can type in this program. Okay, so routine 1. So first we need to get offline. It's better to get offline to do that. Over here I need to remind you to over here is still calling batch switch. I'll change that later because I want to show you the online edit. So we open routine 1. So the exam on, output energize. So this one is PB1. And we have PB2 as the second one, and this one is motor. We have serial bypass. Drag the motor, come back here. So you can see that's exactly the same design as this, right? So we have this. Now we download. So run, close this. If we press PB2, you can see here because PB1 is normally closed, it is on, right? Exam on is true, it's just waiting for PB2 to turn on the motor. PB2 is normally open, right now it's false. So if we press PB2, that become closed, should be on, and the motor should be turned on, but right now it's not. The reason for that is within the program of 3-wire control, my main is the first program to run. So right now with this, we use JSR, we call by switch. So it's still calling this routine. So that's why you don't see any change on there. So what you need to do is to change this to call routine 1. I ask you to online edit, so double click and change this to routine 1. Once we finish, finalize, we call routine 1 right away. So routine 1 is here. Now if we press PB2, you see the motor is on right away. And also because the seal-in, you have 2 paths. One goes through PB2, the other one goes through motor to turn on the output. So now if I release PB2, I still have the second branch to keep the motor going. And then I press PB1, which is stop button, to cut power from here, and the output will become false. So you can see here, that's what we did. So for the 3-wire control, this is start to turn it on, so you don't have to press and hold the button all the time, and you can release because the seal-in, and PB1 is the stop button. So when you press, you cut power, release, it becomes true, but because PB2 is open now, the motor won't start. So we have 2 separate buttons, one at the start, the other at the stop. So this is the 3-wire control for the first one, for the first routine. So with PB2, with the routine 2, we can I'll quickly go through that, right? So PB2 as stop, PB3 as start. PB2 normally open is release. Normally open release, you will see the value 0. And then because of that, we use the exam off instruction to check PB2. And PB3, this time we use PB3 as a start. which is normally open, we need to press the normally open push button. When you press the normally open, you have value 1. But when you see 1, just use exam on instruction. So now we have different input, and over here we have a normally open push button going to PLC, and that's my PB2. And we have the second one also as normally open push button. That's PB3. That's the buttons, the 4 buttons on the HMI. Output, same thing. We have the coil, and the tag is motor. And we already decide the instructions. We can just directly write down here, exam off PB2. Exam on PB3, and output energize motor. And don't forget, the output should come back to seal in this start button PB3. Okay, this is the second routine. Let me finish this. Then let's look at the routine 2. Okay, routine 2. In order to save time, I don't want to go offline anymore. I just keep going with the online. Alright. So over here we have the exam off PB2, and then we have a exam on PB3. Now we have the output energize, which is motor. And don't forget to come back to bypass start button, and we have the motor to seal in. And notice here we added online. So finalize. Now we have the routine 2 finish. If you try it, PB2, you don't touch the start button, you turn it on, you should see motor turn on. Again, that's the same thing. You need to come back here, online edit, to change this to call routine 2. And finalize. We have routine 2 right now running, so it's running now. So motor is on. When I release the button for the start, PB3 is still energized because the seal in, and it will keep energized until I press the stop button, which is PB2. Motor is off now. Okay, so by doing this, you have an idea of what we need to do with the lab. Right? So halfway through, we just need to finish the routine 3 and routine 4. Okay, so again, PB3 is normally open. Actually, up to this point, if you understand what we're going to do, you can just stop the video and continue to work on the rest part of the lab by yourself. If you still need guidance, you can stay here, watch the video to the end. But before you go, I recommend you watch the second video. So there's another video after the lab. We talk about more important part on the safety design. All right. So I'll just continue to finish the routine 3 and routine 4. So we have normally open, it's released. We have tag value 0 as the result. With tag value 0, we use exam off. And we have the PB4 as normally close is pressed. When you press the normally close, we will have value 0, and we need to use the exam off to check PB4. So that is the diagram I need to check with you. This is a normally close push button. Different symbol to represent different type. Oh, sorry, I made a mistake. PB3 is normally open, so let's go back. Okay, normally open. That's this symbol, PB3. Sorry about that. And PB4 is normally closed, so we need to draw the push button like this. PB4. And output, same as before, motor. And exam off, PB3. Exam off on PB4. The output is motor. So you can see this is the same structure with the program. It's just different exam on, exam off, because we have different configurations on the button. So same always will be the motor come back to fill in the start button. So that is the routine 3. Routine 4, we have normally close, release. We have value 1 in here. With value 1, we use exam on. And we have PB1 normally close is press. That has value 0. With value 0, we use exam off to check PB1. Let's design this. So we have PB4, which is normally closed. Oh, no, not here. We can write down here, because that's inside PLC. We use PB4 to represent this button. We have another normally closed push button, and that in PLC is represented by the tag of PB1. Output, same motor. And design that, exam on, exam off, output energize, and that's PB4, that's PB1. We have motor, and don't forget the seal in bypass. Always to bypass the start button. Okay, so we finish all the routines. Let's quickly type in here. Routine 3. So we have exam off, output energize. That's PB3, PB4, and then motor. And bypass PB4, and then motor energize. I'm here, finalize. And this time we don't forget to change that to routine 3. And finalize. and routine 3 here. So PB3 is stop button. We don't press stop button, but we press the start button, which is PB4. So press, the motor turn on, energize, release start button, still energize. But when you press PB3, stop button, motor is off. So that's the routine 3. Let's look at routine 4 here. This is the design on routine 4 and routine 4. So exam on, exam off, output energize, and that's PB4, and that's PB1. Turn on motor. Bypass, and some people call seal in, some people call latch in. So then finalize. Main routine change to routine 4. Let's open the routine 4 and press button. So PB4 is the stop. Right now you can see it's energized. It's just waiting for start button. PB1 right now is off. So when you press, it's on. Then the motor energized. Release, 3 wire still energized, and PB4 turn it off. Okay, so this is all the design with the full subroutines. I ask you to do the online edit when you test out to get the sign off. So that is what we need to do with the lab. Like I mentioned, when you finish this part, I strongly recommend to watch the second video after this one. Within that video, I will talk about the most important concept, the safety design. Alright, I'll see you.